Hi, this is Dr. Jackie Huang, an associate professor in Department of Chemical and Biological Engineering at Villanova University. In this video, I provide you an overview of my book in which I design cool research projects a layperson can do at any time and from anywhere. And before I show you the detail of the book, here is a brief introduction for myself. I got my bachelor and master degrees both from Tsinghua University, which is the top one engineering school in China, and I got my PhD in chemical engineering from Texas A&M University. And after that, I joined Villanova in 2011. I enjoyed my time at Villanova, and which is a beautiful school and in the suburban of Philadelphia. And Villanova is also a top 50 school in the USA and with an outstanding reputation and for academics. And we also have very strong basketball program, and so we got the two NCAA basketball championships in the recently, in 2016 and in 2018. So I have supervised more than 30 PhD and master undergraduate, also high school students in research. And my research area is focused on biochemical modeling and data analysis. And I have published around 39 journal papers and 2 book chapters and 16 conference presentation papers. And I enjoy applying video-based teaching approach in my research and in teaching. And for example, my colleague and I developed some video modules that teach students with the basic biological concepts and also some biological experiment skills, and we presented our work and in an ASIC conference, and we were awarded the outstanding ASIC Martin Award. So in this book, and I use similar approach. I recorded videos and to help students to understand the materials I presented in the book. Here's the outline of the presentation. So I will show you the motivation why I write this book, and also I introduce the outcomes from the previous students who participated in the project. And after that, I will briefly introduce the biomodels covered in this book, and then I will provide an overview of individual book chapters and introduce resources that can be used to help readers in their learning. So now I want to show you why I write this book. So after I joined Villanova in 2011, I found that the math performance of the college students are not as good as I expected, and then I also checked some website and found that the math performance also for high school students lag behind their peers in other countries, especially in the STEM fields. And so here are some data. So for example, so in the program for the international student assessment, and the math performance of the USA high school students are ranked 39. So it's below the average because there's 70 nations here. And also in 2013, and around 56% of US high school graduates were not ready for the college level math. So you might wonder whether the situation for the college student is better. Actually, not really better. So here are some data. So compared to the students in Japan and China, so we have much less students, right, actually got awarded in the STEM field. And also even those students study with a STEM major, and 38% of them actually did not graduate, right? So therefore, so as a educator in the STEM field, right, I really want to do something to change this situation. I know my contribution may be limited, but I just want to do it for the personal interest. So that's why I write this book. So here's the motivation. So in the last 5 years, I work with high school students, also undergraduate students. Actually, those students they did not have a prior experience in modeling, in data analysis, and I just wanted to do some experiment. So how can I teach or motivate those students from scratch, right? And then pick up those modeling and data analysis skills that can be beneficial to their career. So so after 5 years, I did figure out some approaches that can help students and to learn modeling and data analysis, and especially in biological reactors. So here, so this book to try to provide interesting and also doable research project for a layperson who does not have a strong academic foundation in either math, engineering, and modeling and biology. And I also introduced 2 modeling platforms. One is MATLAB and one is R. I will give you more detail on that, and the student can play around and in these 2 platforms and to have fun when they do the project. And I hope this book can help to build the confidence and interest of for the readers, especially in the STEM fields. And I also recorded videos and provide all the code, and then the readers can follow the videos or follow the examples and the instruction in the book, and then finish the research project, and then run those skills and master those modeling and simulation skills that can help them in their career. So here I want to just introduce the first platform actually for the modeling is the Simulink MATLAB, right? So here is example for the MATLAB Simulink. So again, I assume that the reader is a layperson in modeling. So therefore, I will introduce some background information. For example, what is ordinary differential equation, and I begin with a very simple example. For example, the distance of the car, and driving over time, and how can we quantify the distance, based on different acceleration. A is acceleration, and then I show the reader how to present the OD model here, just like building a Lego in MATLAB. So you could ring this module together, and then you could solve the model, and then you could predict, in this example, can predict the distance of the car and drive over time, So I hope to make the book more interesting, and then the students have more fun when they do the project. So this is for MATLAB, and so actually MATLAB is not free, but the student can also use the MATLAB free trial version and for 30 days for free. So I'm correct, and I think it costs about $49 to get a student license, and also some high schools or college, they should offer the MATLAB academic version. Anyway, the readers should check with their schools to see whether they could get the free license first. So I also introduced R because R is one of the most popular statistical analysis tools used in data analysis for example in the academic, like biopharmaceutical engineering area, or also medical engineering area. So also if the reader is not interested in just like putting the blocks together, and some reader may not like a lot of lines and blocks in the program, and then so they could try the R. So in the R is pretty straightforward. You just type in the differential equation here. So actually if you master or you learn R and well, and then you could build the model faster in R than MATLAB, right? So anyway, I try to provide multiple options, right, and to the readers, right? If they cannot finish the project in MATLAB, they can still finish the project in R. So here I want to show you a previous project done by a high school student, and actually it's a microwave fuel cell project. Here, if you don't know, right, actually microwave fuel cells generate electricity from wastewater. So here is cartoon. So we have the anode and cathode, just like the traditional battery, right? But we use bacteria to produce electricity. So we grow specific bacteria, actually we call exoelectrogenic bacteria, on the surface of the anode electrode. So these bacteria, right, uptake organic compounds from the wastewater. Again, for example, the sugars, right, in the wastewater, like glucose, something like that. So and those bacteria, and they convert the organic compounds right, to electron. E is electron, and also there's a protons here diffuse through the cation exchange membrane. So on the surface of the cathode, so we have the electron, the proton. We also have some dissolved oxygen in water, right, and then produce water. And so if you want to know, here are the reactions, right, and chemical reactions, and in the anode and cathode, and you can see, right, the microwave fuel cell and can clean up the wastewater at the same time produce electricity. So it provides a sustainable approach, right, to handle wastewater. And here's what right fuel cell look like. So this anode, this cathode, this is the exchange membrane. Actually, my lab has had those fuel cell, and actually, if you type microwave fuel cell, right, in Google, and you could find a lot of videos and example. So I just want to introduce the first project. Is done by Clement in 2014, and at that time he was a junior, high school student. So I show him the OD model here. Like this model, I don't want to talk too much detail on that, but this model can describe, for example, the concentration of substrate, the populations of the bacteria. We have two types of bacteria in the fuel cell, and then we also have electron carriers here, and then here MFC is the electrical current produced by the microwave fuel cell. So this model is actually is pretty complicated because this QE and QM and mu A and mu M, actually they are equations. Okay, so So we have about 25 parameters here, right? And then the student he learned the MATLAB Simulink and build the model, right? In Simulink, and he successfully used the model to quantify the electrical current signal, right, for the fuel cell, and for different flow rate, right, of the substrate. And also he also used the model and to quantify the electrical current signal for different the flow rate. This one is the time profile, right? This for one flow rate, this one flow rate and the another flow rate. And then this one is the current signal for multiple flow rates, right? And then based on that, we could design the best flow rate, for the fuel cell to get the maximum, electrical current signal, right? So anyway, so the student and learn a lot, and then also can use the model to optimize the operation of the microbit fuel cell. So here is the outcomes, right? So here's Clement, right? And he presented the research, right, in the ASIC conference. He was the only high school student presented the work in the ASIC conference. And after that, and then I recorded the videos and then put the projects on the website. And then there's two more students, right? Here's Pablo and Carol, and also finished the project just by watching the YouTube videos, and then presented the work also in another ASIC conference. So after that, I also try to introduce R and MATLAB to find high school students here, and then I want to know, hey, whether it's doable to introduce R to students. And actually all the students finish the programs in both R and Simulink, and then we publish the result in the Chemical Engineering Education Journal, right, which is is one of the best journal in the education, especially in chemical engineering, right? So all this work actually is based on my experience in video-based teaching. And actually I developed, for example, inverted classroom approach to educate college student in MATLAB and in chemical process control. This is the course I teach at Villanova. And I also developed a lot of modules in chemical engineering, and that can be shared by other faculty around the world. All right. So anyway, so I think I have around 10 students, participated in these projects, and then some of them got accepted by top university like Princeton, UPenn, Cornell, Michigan University, and then UCLA and McGill University, so this is the number of students that are accepted by those universities. So here are some testimonials from my previous students. So actually Clement, he was the first student, got the project done. And now actually in this past summer, 2019 summer, he worked as a undergraduate research at MIT, and then he told me what he had learned from the book benefited himself a lot in his college, and also also in the summer research project. So Clement was accepted by Cornell, but he decided to go to University of Pittsburgh because he got good scholarship there, and also Paypal. She also got the offer by Cornell, but she decided to go to UCLA because she likes the location better. And so here's the comment from Paypal, and then she mentions that the project is doable, right? All right. Also, the project also provide a lot of information about microbead fuel cell that, and help her to decide to stay in the environmental engineering major. So Frederick is the right, as another student. Actually, he just got accepted by Princeton in this year, like 2019, right, summer 2019. And he mentions that this research experience helped him, right, and in his application to Princeton University. Okay, now I just now want to briefly introduce some biomodels, right, introduced in presented in the book. So I try to motivate the readers using some examples that are related to their daily life. For example, I will introduce the biochemical reactions that related to the immune response. So here, for example, when people get burn on the skin, and then people get inflammation, and some some proteins like actually cytokines like interleukin-6, and is secreted by the white blood cell around the wound, and then this protein just like the alarm of the building. For example, if there's fire, the alarm is on, and then now because there's a wound here, so this cytokines just secreted, and then they translocated to the liver cell, and then they stimulate the liver cell. We call also hepatocyte cell, and then regulate the concentration of acute phase proteins like albumin, and then C-reactive protein, and then these proteins determine how the human body responds to the inflammation, to the burning, right? We call this is just like the signal transfer from the skin to the liver. We call this signal transduction pathway. And so for example here, so this is a liver cell, and then there's a specific receptor to the IL-6, right? So the IL-6 just like a key, and then this receptor just like a lock, and then the key turn the lock, and then initiate cascade reactions here. So again, I don't want to talk too much detail about this, but this reaction, the outcome of the reaction is there's some acute phase proteins that are synthesized, and then also called expressed in biology, right? And okay, so anyway, this signaling pathway actually is, has around 70 reactions. It's very complicated, but most of this reaction can be described by enzymatic reaction, which are the one I introduced in the book. So here's another enzymatic reaction. For example, if you have if you like the sugar cane, and then you eat the sugar cane, you feel the sweet in your mouth, because in your mouth you have in the saliva, and then there's a kinase called sucrase that can convert the sucrose to the glucose, right? And then you feel the sweet. Anyway, so in this very complicated reactions, most of them can be described by this enzymatic reaction cycle. And then in the book, I showed the student how to develop the model for this kind of reaction, right? I also introduced some important principles used in model development. For example, what's chemical kinetics, mass balance, and also after that I showed them how to solve the model in both R and Simulink. And so also based on the model, there's a lot of things can be done. For example, we could use the model to identify the elections, the most important elections that can be used to regulate the response of the cell to the wound, right? For example, different patients, they had different reactions. Based on that, we also can design personalized medicines to help patient. So anyway, I will show students how to apply the modeling approach and to solve some real world problems that can benefit the health of the patients, and also to produce bioenergy, just like the microbial fuel cell. So here some examples of the models I introduced in the book. I begin with the core and then also the water tank, because they are related to our daily life, and then it's easier for the readers to understand. So I also show them how to solve the model, and then after that again I will begin with the enzymatic reaction, right? So the core and the water tank model, actually they only have one equation, and then move it to multiple equation here for the enzymatic reaction, right? And this happened in within one, this one only one reaction, right? Typically inside the cell, in one cell, and then I move to one cell to multiple cells here. This we call fed batch bioreactor. So we feed the cell with the substrate, and then we extract the product, right? This is the bioreactors that commonly used in the pharmaceutical industry. So this model can be used to design the best operation condition, right, to improve the products from the bioreactor. So after that, and then I will introduce the microbial fuel cell. Okay, so now let me just show you, right? So in the book, I will provide step-by-step instruction. And so for example, here's example. So for this equation, I showed students how to decompose the equation into different levels, and then how to represent the equation, using the modules provided in MATLAB. So in R, it's actually I will show the student how to type the equation in R, right? So the book is printed in color, and then again the very detailed instructions step by step, right? And also, I also recorded the videos, right, in case the student the reader has difficulties to reproduce the programs from the book. So here is overview of the individual book chapters. So I provide an overview of the book, and then show students how to install MATLAB and R. Actually, it's in MATLAB first, and then I introduce some basic concepts of ordinary differential equation, and then I show the readers how to solve the ODEs, express the car model, the running car model, and also the water tank model in Simulink. So based on this, and the readers should know how to solve simple ODE model. And after that, I introduced some important concepts, for example, chemical kinetics and mass balance, right? How to get the model from the reactions. And then I will show a more complicated model for the fed batch bioreactor, right? And then show them how to solve the enzymatic reactions, and then the fed batch bioreactor in MATLAB Simulink. And after that, I will introduce some basic concepts, in electrical engineering, and then electrochemistry, and also microbiology. So more about microbial fuel cell, also the components of microbial fuel cell, and then I will introduce the ODE model for the microbial fuel cell in detail, especially the physical meaning of each term in the model. And then after that, I show student how to build a model in Simulink. And so again, if the readers want to begin from R, so the reader do not have to build a model in the Simulink, but the reader still need to read the sections especially for the theoretical introduction, for example those basic concept introduction, right? So in the first few chapters. Again, if they don't want to do the simulation in Simulink, right? They could just, after they read those basic those sections for the basic concepts, right, and then they could jump to chapter 5, just install R, and then build the models in R, right? So so the reader can either build a model in Simulink, or build a model in R, or build a model in both Simulink and R, right? Okay, and so for each chapter, I have some practice exercise, right, for the student. Just change the programs in the examples, right? Just play around to understand the models better. And then in the last chapter, I provide 2 mini projects, right? One is for HIV, infection of the T cells. Another one is the immune response in the cell to the tumor growth, right? So in this chapter, I do not provide the videos and also the codes, because these are the mini projects that the student can practice their modeling skills learned from the book. Okay. So here are some resources. So I record videos for each example from chapter 1 to chapter 5. All right. And I don't have the programs for chapter 6, right? Because I want to give you a chance to practice. Again, those videos, actually this typo here, the videos only cover the coding section, and the reader should read the book, right? For those theoretical section. Okay. So again, here is the video, and so all the videos, if we add all the times together, is about 10 hours, right? So I expect you to spend about 10 hours, right, to finish the programming. But you might need to spend more time, right, in reading the book. Again, if you want to get the link for this videos, you could just go to the website of the book, right? And also after you finish either you finish the program in either Simulink or R, or in both Simulink and R, you could also go to the website and then to place a request for your program evaluation. So in each week, I pick one student to evaluate his work, and then provide a letter to prove that the student master all the programming or the modeling skills that introduced in the book. You don't have to finish the mini project to get your project evaluated, right? And then you don't have to do the practice exercise. But if you want, right, you could also do the practice exercise, also to finish the mini projects, right? Okay. So to get the evaluation, you need to finish, right, chapters 1 to 4 for the Simulink, or chapter 5 for the R, or both Simulink and R. Okay. And also I offer free UT videos for these projects before, but it did not work that well, and I think there are 2 reasons. The first one is the readers did not have any commitment to the YouTube's videos, right? Because they are free, so the reader may not pay too much attention to those videos. And also right, in those YouTube videos, there's no there was no book and to introduce those basic concepts and theoretical background. So that's why I write this book. And also I do want the readers to buy the books and then make a commitment and then try to finish the book, right? Because they buy the book, they should finish the book, right? But I understand, right? For some students, right, they may not be able to buy the book, and so therefore I offer a book gift program. So you could go to the website here and then put a request. Right, I might mail the books to those students, right, as Christmas gifts. But again, right, I can guarantee, right, each student, right, because it depends on how well the book, right, is sold. But I do want to get as many students as involved in these programs, and I do want right, the readers can learn a lot from this book and then master the modeling and then programming skills that can benefit right, their careers. So we are done with the overview. Right, again, you could go to my website and to also provide some feedbacks on the book. Thank you very much.